Hi, my name is Martin Sneedlager. I'm a Senior Technical Product Manager at PTV, and I will guide you through a series of webinars, all focused on ABM and Visum. Today, I will be discussing Visum's role in the world of activity-based models. It focuses on the collaboration between Visum and other ABMs, as well as the specific ABM functionality of Visum. Let's get started.
Before we begin, I would like to briefly discuss the expression ABM. Normally, the expression ABM is used for activity-based models. However, sometimes it is also used for agent-based models. In fact, neither of these model classes is really well defined, and the difference between the two is not always so clear even among scientists. In any case, in this webinar, when we use the expression ABM, we mean activity-based models. First of all, I would like to address the motivation. Why do we actually have to deal with ABM? Well, in recent years, the topics and planning issues have changed a bit. For example, while the focus used to be more on new infrastructure, today it is more on the utilization of existing infrastructure. Then the focus shifts from motorized transport to active modes such as bicycles, e-bike, walking, and so on. Instead of complete bans on transit, we are more likely to analyze temporary measures such as morning toll, congestion charge, and so on. And there is much more. All these new issues and questions seem to be much more fragmented and individualized, and the question arises as to whether traditional macroscopic models, such as the four-step model, are able to cover all these challenges. And this is where ABM comes into play. Actually, ABM does not describe a specific type of demand model. Rather, it represents a class of model types. There are many different ABMs, and they differ greatly from one another. Here are just a few examples. The question arises, why do we need yet another model type? Why is Visum adding its own ABM? Well, all these ABM types are far from forming something like a standard model type. They focus on different aspects of mobility. The microscopic aspect is important, but so is the dynamic data structure that enables dynamic pricing. Others are focused on intermodality, especially DRT, active mobility, in particular in the context of public transport access, and so forth and so forth. And we also have certain ideas about what is most important to our customers. So even if we wanted to support something like the leading ABM approach, it wouldn't be possible. But there are further reasons for our own ABM. The typical ABM software looks like this. There is an input that goes into a machine, the ABM machine, and produces an output. So far, so good. However, the input data is quite difficult to maintain. It is just a bunch of text files. And the same applies to the output. And the core, the ABM machine, is even worse. It is a Python script. And not just one, but a set of hundreds of such Python scripts. And since it is usually traffic engineers working with ABMs, the ABMs behave like a black box. Very few people really know what is going on. And very few people really know how to define the input data correctly. However, these ABMs are valuable and important, even if they are not very user-friendly. That's why Visum has two different ABM strategies. The first strategy is to embrace external ABMs. Visum provides the data structures, editors, and analysis functions. All data can be stored and maintained in Visum. Visum acts somehow as a platform for external ABMs. The core ABM is located outside, but can fully be controlled by Visum. The input data for the ABM is exported in the appropriate format, the ABM is started, and the results are imported into Visum. In this way, the core ABM continues to function as a black box, but it is much easier to maintain. For the special case of ActivitySim, a quite popular ABM software in the USA, we have already integrated the import and export functions as regular procedures in Visum. Visum also offers an importer for the synthetic population that is optimized for PopulationSim, another software from the ActivitySim consortium. Visum thus provides a suitable environment for a smooth workflow with an ActivitySim ABM. However, as stated earlier, we do not believe that such black box solutions are optimal tools for a traffic engineer. They usually require some programming skills, and the underlying theory is often so complex and complicated that it would fill an entire university course. As a result, there is often only a relatively small group of highly qualified specialists who can create and maintain the model. That is why we have developed Visum's ABM. The most important aspect in the development of our solution was user-friendliness. Any modeler who is able to model a four-step model in Visum should be able to model an ABM without much training. Another aspect is disaggregation. The ABM is spatially disaggregated. It is based on locations instead of zones, and it is disaggregated in terms of time of day. This allows, for example, the use of peak and off-peak travel times. A core feature is its stability. Instability, as found in most ABMs, is completely unknown to traditional modelers, and it is hardly acceptable, also for end customers. Instability makes it difficult to separate a systematic effect from random noise. That's why we have completely eliminated random noise. Small changes in the input data lead to small changes in the output. And last but not least, it is of course important that ABM improves the ability to answer the most important current questions and to meet the current challenges for models.
That's all for today. I hope you liked today's session. Join me next week, Monday, to explore Visum's ABM mechanisms.